Ultrasound inspection for predictive maintenance and reliability is being specified as a go-to instrument for managers working with reduced budgets, tighter deadlines, and lower tolerance for unplanned downtime. Hi, I'm Alan Reenstra with SDT Ultrasound Solutions. In this short presentation, I'll tell you why your predictive maintenance program needs ultrasound right now. Ultrasound should be the heart of every PDM program. Ultrasound makes peer technologies like vibration and infrared work better. Ultrasound is symbiotic and complementary, yet it stands on its own. Ultrasound is inexpensive to implement and operates and repays your investment overnight. Ultrasound instruments detect, measure, and collect ultrasound pressure waves that are airborne or structure-borne. Airborne detection is for compressed air and vacuum leaks and electrical activity. Some mechanical issues are detected in airborne mode as well. We also detect ultrasound through a structure such as a bearing housing, gearbox, steam trap, or valve body. We collect two types of data, static and dynamic. Static data is a single data point. That can be a decibel, a temperature value, an RPM value. A dynamic measurement is a time signal. That data is stored as an ultrasound wave file and is analyzed much the same way vibration data can be in both the time and frequency domain. Your factory floor is a noisy place, and your senses are deafened by the roar. But everything we hear with our ears has a corresponding ultrasonic component that we can't hear. An ultrasound detector lets us focus only on high-frequency ultrasound, which is more directional and localized to its source. This super hearing capability lets us hear, measure, and trend problems that waste energy and lose production time. Quality ultrasound instruments distinguish characteristics of ultrasound. A bearing sounds like a bearing. And if it's starved for grease, its tonal quality is reflected in the headphone output. Likewise, a compressed air leak carries a distinctive swooshing sound, while pump cavitation sounds like a popcorn machine. The clarity of the SDT 270 makes it easy to distinguish between the ultrasound produced by a compressed air leak versus the ultrasound produced by internal turbulence in a pipe. Detected ultrasound is measured, trended, alarmed, and analyzed, making quality detectors like the SDT 270 a diagnostic instrument, not merely a troubleshooting tool. Finding compressed air leaks, pressure leaks, steam leaks, and hydraulic leaks are just some of the reasons that ultrasound detectors were invented all those decades ago. But today's evolutionary devices do so much more. If you listen to an electrical system and hear buzzing, popping, and crackling sounds, well, you've just discovered a fault condition categorized as either corona, tracking, or arcing. This needs to be looked at. Capturing dynamic ultrasound signals from electrical phenomena allow us to analyze the severity of the effect, but also its category. Take a look at the time wave and spectrum shown here. Listen to the ultrasound file captured by the SDT 270 device. The top image illustrates the time domain showing the buildup and release of the ionization discharge as it finds its path to ground. Ultrasonically, we hear the buildup and then an interruption or neutralization of the air surrounding the problem. Heat does not build up here until the situation progresses and there is sufficient flow or current to produce heat along the discharge path. The bottom image illustrates the frequency domain. Note the repetition of 60 Hz events. Clearly, that's nuisance corona. Also note the noise levels between the 60 Hz peaks, which are a confirmation of tracking activities. We confirm its tracking because of the time view and the fact that no heat was detected with an infrared camera. Rubbing, impacting, and friction levels in rotating equipment are detected with ultrasound first. Since we have the ability to measure these conditions both as static and dynamic data, ultrasound is useful as a trending tool. It alerts us to changes and warns us of failures. Ultrasound detects non-repetitive problems earlier than other predictive technologies. So use the technology as a filter for your vibration team. Use ultrasonic trends and alarms to prioritize vibration analysis tasks. This lets your vibration guys concentrate on problem machines and saves them the time wasted analyzing bearings that are not in failure. Avoid over-greasing bearings. Ultrasound is a wonderful tool to help guide lube techs. Use it to decide when to grease and how much grease to add. As a symbiotic partner to vibration analysis, use this evolutionary technology to monitor rotating equipment, non-rotating equipment, and of course those slow-speed bearings. Listen to the ultrasound file captured on this bearing as it receives a single shot of grease. Compare it with a time waveform, and there can be no doubt that lubricating this bearing had a positive effect. Lots of companies already enjoy the benefits of an effective ultrasound program. Wholesome Cement uses ultrasound to monitor the condition of their plant's rotating equipment. Their clinker cooler fans are critical to the process, and ultrasound has proven a fast and effective tool in their harsh, dusty environment. Wholesome also recognizes the value of compressed air leak detection and is implementing operator training for their ultrasound inspectors to ensure all applications are optimized. General Mills uses ultrasound monitoring as a first line of defense against greasing issues in high-temp bearings used on their cereal cooking lines. Lubrication failure is common when high temperatures cause the oil to separate, making lubricant less effective. The waxy residue also blocks the annulus of the bearing, preventing fresh grease from reaching its destination. Rio Tinto is a global producer of minerals. Certain mines use ultrasound to find leaks in the air intake of diesel engines, which causes dusting. Silica in the engine oil damages engine components on loaders and other mobile assets to the tune of millions of dollars every year. A separate white paper dedicated to the inspection of mobile assets is available from our website, www.sdthearmore.com. Alcoa Mount Holly, they won an industry award for their ultrasound leak program. They documented huge savings and were recognized by their peers and also corporate upper management. Anheuser-Busch makes good beer, and they make it profitably. They implemented mandatory ultrasound testing across all breweries and tied plant managers' bonus to the results. Their focus on compressed air, steam, and carbon dioxide leaks netted substantial savings. The Church of Latter-day Saints printing division has dramatically decreased downtime since implementing ultrasound testing on their printing presses. Now, Potash Corporation of Saskatchewan takes dynamic ultrasound measurements on slow-speed bearings, a problem diagnosis for vibration analysis. The technology is in use at several plants across Canada. The Smithsonian Institution, everyone's favorite museum, uses ultrasound to ensure their steam systems are healthy. They're a long-time power user of ultrasound testing. The technology was even implemented to test the tightness of a hyperbaric display that houses the original Star-Spangled Banner. Climate control is essential to preserving this important national treasure. Mexichem, a major Mexican petrochemical group, is optimizing their lubrication processes with acoustic lubrication monitoring company-wide. Where will your ultrasonic applications take your program? A white paper entitled Strategies for an Effective Ultrasound Program is available at our website. This document teaches you how to identify applications that would benefit you right away and for the long term. It discusses goal setting and goal assessment, equipment selection, and what to look for in a training and implementation consultant. Suggestions for revisiting your goals and documenting your successes are all part of the follow-up plan. To learn more, visit www.sdthearmore.com today. We're ready to help you start hearing more right now.